Welcome to today's video, where we're going to dive into a fascinating problem regarding type inference in functional programming. The problem we're going to discuss revolves around the covariance and contravariance rules when dealing with function types. These rules play a crucial role in determining the relationships between different types when working with functions. Now, let's explore the solution provided for this problem. In the first part of the solution, we see an example where the identity function is used as the simplest rearranger of lists. The code snippet demonstrates how the identity function can be applied to rearrange lists effectively, showcasing the power of simple, yet elegant solutions in functional programming. Moving on to the next part of the solution, we encounter a scenario where a predicate about identity functions is compared to a predicate about list rearrangers. By leveraging the fact that the identity function will always be called, the code snippet emphasizes the importance of selecting appropriate functions based on the specific context in which they will be used. Continuing with the solution, we come across a function that computes an integer from a single list of values of any type. The provided code showcases how a function that doesn't actually use its argument can serve as a suitable replacement for scenarios where a constant integer function is required. Next, the solution highlights a case where a constant function is requested, but the use of the length function is deemed inappropriate due to its examination of the argument. This example underlines the significance of understanding the specific requirements of a function when selecting the most appropriate implementation. In the following part of the solution, we explore a function that computes an integer from a source of lists of any element type. By demonstrating how the only possible input in this scenario is an empty list, the code snippet reinforces the concept of tailoring functions to the expected inputs they will receive. Lastly, the solution concludes by addressing a situation where a function makes an integer from a magical wellspring of anything, highlighting the importance of considering both function arrows and quantifiers when determining the variance between different types. In summary, the solution provided offers a comprehensive exploration of various scenarios in which different functions can be applied effectively based on their specific characteristics in intended use cases. I hope you found this discussion on type inference in functional programming both insightful and engaging. Remember to like, subscribe, and comment below with your thoughts on today's topic. Stay curious and keep coding.